Hello guys, welcome to Deep Codes, and in today's video we will discuss unique paths in a grid, that is the Kickstone Grids problem of the day. And here you are given a grid of size n cross m containing zeros and ones. See, 1 means you can travel through that cell, 0 means you can travel through that cell. Initially you start from 1 comma 1, that is the starting position, and you need to reach the bottom right corner, that is n comma m. And you need to calculate the total number of paths possible from this starting node to this ending node. You need to calculate total number of ways to reach your target node and do a modulo so that you don't reach out of bound, or means you need to return answer in integer, and that's why we do modulo here. And you need to note one thing, that the starting node as well as the ending node can be 0. So if any one is 0, then your answer will be always 0, means you won't be able to travel, right? Correct. So if you take a look at this first example here, so your initial position is this, and this is your target position. How many ways you can reach to this target position? See, one way is this, by taking this one, this one, this one, and here. Second way is this. So you can see that there are only two ways to travel from this starting position to the ending position. So we treated 2 as our answer. Now let's say if you have something like this here. So this is the starting position, this is the ending position, and in between there is only one cell, and that is 0. So you can't travel from the starting to ending because the between cell is 0. So there is no path. Got it? So if you have something like this, let me draw one matrix. Let me 1 0 1 1 1 1 1 1 1. So yeah, you let's assume you have something like this. Then there are multiple paths. See, one path is from this to this. This is the starting and this is the ending. So this is one path. Then the another path would be from this. Another path would be from here. Okay, so there are multiple paths you can see, and you can only travel in two direction. There is either right or down. So if you think something like doing something like this and taking up the above path, and you will do like something like this, then this is invalid. You can only travel towards the right and towards the down. So each time, for each cell, you can say for each cell you have choices. You have what? Choices. What choices you have? Choice to move towards the right and choice to move towards the down. Okay, so you have two choices, and what we need to find? We need to find the summation of two choices, like how many answers we get from the right and how many answers we get from the down. Yes, total answers, right? Total answer x, total answer y, and we need to just sum it for each cell. Correct? And yeah, that's simple. What we would do, we would write a recursive solution. See, since there are choices, then what we can do, we can write a recursive solution. Correct? Recursive solution, and further we can memorize it to reduce the time complexity. Correct? And one thing to note here is we will also have to keep one visited array to mark that cell as visited or not. Okay, so these three things we need to keep in mind while coding for this solution. So this is an easy equation, like, because once you understand that we have choices for each cell, we can easily write recursive solution, and memorizing the recursive solution is easy enough, right? And the only thing we need to take care is visited array. So this visited array we would mark as 0 and 1. Then 1 means it's visited and 0 means it's not visited. Correct? Simple as that. So yeah, let's now move on to the coding part where we will understand this in detail. So let's say you have so initially we took this mode and this dp vector. So starting what we did, we resized this dp vector to n cross m and store -1. -1 means not visited, or we don't have any value for that particular cell, and we then called the solve function. So in this solve function we passed the two I and j, that would be the coordinates of the cell, the index of the cell I and j, the total number of rows and columns, and the grid. So this is the base condition that we wrote here, that if I is greater than equal to n, or j is greater than equal to m, or grid of ij equals to 0, that means we can't visit. If it is 0, then we would return 0. Correct? This is the base condition, or you can say terminating condition. Then we check if I equals to n minus 1 or j equals to m minus 1, that means we reach our destination. This is our destination. So if we reach our destination, we will return 1. Why 1? Because that is one possible way. We found one possible way. So we return 1. And then we check that if for current cell we have some answer or not. If we have some answer, then we directly return dp of ij. Simple as that. Okay, so this is all some computation we did. And this is where the real calculation we are doing. So we are making grade of ij equal to 0. See, if it would be initially 0, then we would have written 0, but it was 1. So that grade of ij that was 1, we made from 1 to 0 here. So why we made 0? So that to mark, so that we don't visit it again. So we are not using any visited array separately. We are just simply doing that concept of visited array with the help of grade by making it to 0, by converting from 1 to 0. I hope you got this. And yeah, we had two choices: one to move to the right, that is I plus 1, and one to move towards the down, that is j plus 1. So we use one answer variable, store both of them by taking mod everywhere possible. Okay, and then after traversing to both right and down, we again make grid of ij to 1. Correct. Initially we converted from 1 to 0, then again we converted from 0 to 1 to original state, and yeah, in the end we return our answer. We return dp of ij equals to answer. Simple as it is. So yeah, this is how this recursive function works. That I hope you guys understood that what all things we are doing here: terminating condition, checking the if we are reached to the destination or not, then checking that if the cell is already traversed or not. Okay, and everything is done. Then we are marking it at visited, traversing right and down, then again marking to the original value and storing our answer. Got it? So yeah, this is how the dynamic programming approach works here. And yeah, this is all for this question. Now talking about the time and space complexity. So here the time complexity would be big O of n into m, and also the space complexity would be big O of n into m. For this solution, see, if you would have write only recursive solution, that it would be 2 to the power of n into m. But since we are using memoization, so it reduced to big O of n into m. Got it? The number of subtrees here formed would be reduced. So yeah, that's all for this video. Make sure to like this video and subscribe to our channel. Thank you.